So this is the next question 2b. Draw the mechanical network for system shown and write the equations of performance and draw its analogous circuit based on Fi analogy. Okay. So here we can see that this is not a translational mechanical system. In this problem they have given the rotational mechanical system, okay, where we know that this theta is the angular displacement and this is not force, this is torque, okay. It is represented by tau of t. We know that in rotational mechanical system, in place of force we are writing it as torque, in place of displacement we are writing it as angular displacement, and in place of mass we are representing it as the moment of inertia, that is J, and this is the torsional spring constant and this is the torsional friction, okay. So please, you should be knowing this kind of terms, and this is for rotational mechanical system, sorry, rotational system, not the translational system, okay. So for this the substitution remains the same, okay. Whatever we do for a translational mechanical system, so just we need to be assuming this J as equal to M, and the rest all the terms B and K should be doing as it is remaining. So here draw the equivalent mechanical system. We know that we have theta 1, theta 2 and theta 3, so 3 angular displacements, so we should be drawing 3 nodes here, okay. And from theta 1 we can say that this K1 is between these 2 angular displacements, so that's why K1 lies between theta 1 and theta 2. And also we can see that this tau, that is torque lies in the first theta 1 is due to the angular displacement theta 1, so that's why from this node draw the T of t here. Then we don't have any other for T1, so here we can see that from theta 2 we have this moment of inertia J1, and along with that this spring B1 is also causing this moment of inertia, so that's why J1 and B1 we should be drawing from the same node of theta 2. And also between theta 2 and theta 3 we have this B3, because we have the friction causing between J1 and J2, okay. We know that J1 and J2 are causing from theta 2 and theta 3 respectively, so we can see that the friction is between theta 2 and theta 3. Similarly, in place of theta 3 we have this spring K2 caused by this angular displacement, and J2, this is also caused by this angular displacement, and this B2 is due to the moment of inertia which is caused by J2, so that's why this B2 also is caused due to the angular displacement theta 3, okay. So like this equivalent mechanical system we should be drawing. Then the same thing, since we have 3 nodes, so we should be writing 3 equilibrium equations at all the 3 nodes, okay. So the first equilibrium equation at node 1, that is tau of t is equal to K1. We have tau of t and we have only one component K1 from this node theta 1, so that's why K1 into theta 1 of t minus theta 2 of t, because the K1 lies between these 2 nodes, okay. So at node 2, that is at theta 2 of t, we can see that we have K1, J1, B1 and B3, 4 components. So one by one, start from J1 d square theta 2 divided by dt square, plus B1 d theta 2 by dt, plus B3 since it lies between theta 2 and theta 3, so that's why d theta 2 by dt minus d theta 3 by dt, plus K1 into, so again K1 lies between theta 1 and theta 2, so that's why theta 2 minus theta 1. So this is the equation, name it as equation 2. So similarly at node 3 we have the components J2, B2, B3 and K2. So again the same thing, write the equilibrium equation, okay. That is J2 d square theta 3 by dt square, B2 d theta 3 by dt, and B3 lies between theta 3 and theta 2, since we are taking with respect to the node displacement theta 3, so that's why d theta 3 by dt would be coming first. Then like this the equation you should be writing. So in this case they have mentioned you to write the force current analogous circuit, so that's why you should be applying FV analogy condition for all the 3 equilibrium equations. For equation 1, force is replaced by current I of t. Then we know that since we have since in place of K we should be replacing it by 1 by L in place of Fi analogy, so that's why K1 should be replaced by 1 by L1, and the displacement, angular displacement, should be replaced by phi, okay. And again phi is, we know that V is equal to d phi by dt, so that's why phi would be, if you bring this d by dt to other side, it would be integration of V, so that's why phi 1 is integration of V1, phi 2 is integration of V2. Take the Laplace transform, then I of s is equal to 1 by L1s into V1 of s minus V2 of s, so name this as equation 4, okay. Then again same thing, try to write the FI analogy for equation 2 using second equilibrium equation. Substitute in place of B, in place of J, substitute it as C. In place of B1, substitute it as 1 by R1. Okay, in place of K, substitute it as 1 by L1. Okay, so do necessary substitutions. Okay, we also know that it is d phi by dt is equal to V, so that's why we are getting C1 dV2 by dt, 1 by R1 into V2, 1 by R3 into V2 minus V3, and 1 by L1 into integration of V2 minus integration of V1. Again the same thing, take the Laplace transform and write the equation in Laplace transform here. Okay, this is the Laplace transform equation. All the necessary substitutions, the d by dt is replaced by s, and integration sign here is replaced by 1 by s. All the I've done it, so please note it down and note it as equation 5. Then similarly for equation 6, again do the same thing. Write the equation by seeing the equilibrium equation, do the necessary changes required. Then substitute in place of d phi by dt v, and in place of phi integration of v. Then take the Laplace transform and write the equation in s domain. Okay, again in place of d by dt and integration sign, replace it by s and 1 by s and write the equation. And using the equations 4, 5 and 6, we can write the equivalent electric network in FI analogy. We know that in FI analogy we should be using the node analysis, so that's why we should be considering the node voltages first, that is V1 of t, V2 of t and V3 of t. Draw 3 separate nodes and check for compare all those 4, 5 and 6 equations. From that we can see that this inductance L1 lies between V1 and V2, and this resistance R3 lies between V2 and V3. First draw them, and from V1 we don't have any component. From V1 we have one current source I1, that is I of t. Then from V2 the components we should be connecting in parallel. Okay, we know that, so FI energy circuit should be connecting in parallel. R1 and C1 are in parallel. Similarly C2, R2 and L2 are in parallel, like this. Okay, so this is the required FI analogous circuit for this problem. So hope you understood this problem. This is very important, so please note it down. So this is the next question, 2C. Okay, so here they have given one mechanical system here. Okay, and also they have in this they have told us to write the differential equations by seeing this translational mechanical system, but I have written the equivalent mechanical system equations along with the circuit. I have done it for both FV and FI analogy circuit. Okay, so those who want to can refer it, or else those who are really interested only to write the differential equations, they may not draw the circuit. Okay, so here see this translation mechanical system. So two masses, so we can say that we are having two displacements, and here we have one dispenser. So here K2 is connected between M1 and M2, so we can say that K2 is between these two displacements X1 and X2. Then we can see that M1, K1 and D1 and also F of t are all connected to this displacement. So that's why from this node connect all those components, that is f of t, b1, m1 and k1, and also from this m2, that is the second displacement x2 of t, we have this one k2 spring, and along with that one this m2. Okay, so this is the equivalent mechanical network. So we have two nodes, so two equilibrium equations, write them down, that is f of t is equal to m1, b1, k1, these three are there, so m1 and k2 also is there, m1 d square x1 divided by dt square plus b1 dx1 by dt plus k1 into x1 plus k2 into x1 minus x2. So name it as equation 1. Similarly at node 2, since we have only two components k2, m2, so that's why m2 d square x2 of t by dt square plus k2 into x2 of t minus x1 of t, since we are taking with respect to the second displacement x2. Okay, so this is the name it as equation 2. Then for FV analogy for equation 1, m is replaced by L, b is replaced by R, and k is replaced by 1 by C. I have done all the necessary substitution, and x is replaced by q and f is replaced by v. So that's why we are getting L1 d square q1 by dt square, R1 dq1 by dt plus 1 by c1 into q1 plus 1 by c2 into q1 minus q2. Okay, so we know that dq by dt is equal to I, also q is equal to integration of I. So I have replaced those terms. So L1 di1 by dt plus R1 I1 plus 1 by c1 into integration of I1 plus 1 by c2 into integration of I1 minus integration of I2. So then take the Laplace transform and represent it in S domain. V of s is equal to replace d by dt and integration sign by s and 1 by s respectively, and write the equation here. After writing it, name it as equation 3. Again for second equilibrium equation, do the necessary substitution. M is replaced by L and K is replaced by 1 by C. Do the necessary substitution and take the Laplace transform and represent it in S domain. Okay, say d by dt and integration should be replaced by S and 1 by S again. Same thing. Name this equation as equation 4, and if we compare equation 3 and equation 4, okay, we would be getting the equivalent electric network in FV analogy part, where we should be using the mesh currents, okay, that is loop currents I1 and I2, okay. And we can see that this capacitor C2 lies between these two loops, okay, since we have I2 of S minus I1 of S, and this capacitor C2 is common for these two equations. So we can, if any component is common for any of the two equations, so that we can say that though that component is lying between the loops I1 and I2, okay. So like this, the C2 would be coming between I1 and I2, and L1, C1, R1 should be connected in series in the loop I1, and L2 should be connected in the loop I2. Similarly, for FI analogy circuit, for equation 1, that is first equilibrium equation, try to write the equation for I of t is equal to C1 d square phi 1 by dt square plus 1 by R1 d phi 1 by dt plus 1 by L1 into phi 1 plus 1 by L2 into phi 1 minus phi 2, okay. Then the same thing, I of t is equal to C1 dv1 by dt plus 1 by R1 into V1 plus 1 by L1 into integration of V1 plus 1 by L2 into integration of V1 minus V2. Take the Laplace transform and represent it in S domain. Do the necessary changes and name the equation as equation 5. Again, for same thing for equation 2, do the necessary substitution. C2 1 by L2, okay. M is replaced by C and K is replaced by 1 by L. So d phi by dt is V, so that's why we are getting C2 dv2 by dt plus 1 by L2. Phi 2 is replaced by integration of V2. Similarly, phi 1 is replaced by integration of V1. For this, take the Laplace transform. D by dt is represented as S. Integration sign is represented as 1 by S. So that's why C2S into V2 of S plus 1 by L2S into V2 of S minus V1 of S. Name it as equation 6 and try to write the equivalent FI analogous circuit here. Since we should be using the node voltages, since we are using the node analysis when we represent the circuit in FI analogy, so that's why name the two nodes V1 of t and V2 of t. So you can see that L2 component, that is inductance L2, is common for these two equations, okay. So that's why we can say that it lies between these two nodes V1 and V2. So draw it separately like this. Then rest all the components for V1 and V2 eternal are there. Represent it in parallel, okay, that is C1 R1 L1 in parallel, and C2, since we have only one single component, so that's why it is C2, and one current source I of t. So this is the required FI analogous circuit. So they have not mentioned it to draw the FE and FI analogous circuit. They are only told to write some of the differential equations by substituting the equilibrium equations in both FI and FE analogous circuits, okay. Those who want, you can write this circuit as well, okay. Marks will not be detected. So this is the solution, so please note it down. So this is the next question, 3a, that is derive an expression for the closed loop transfer function for a negative feedback system, okay. So this is the question here. First, what we need to be doing is, so consider one canonical block system, okay, where we should be representing one canonical block system which would be having one minor loop, and this is the feedback path, and this is the input side R of S, and this is the output side C of S, and this is the gain here that is represented as G of S, and the gain path is represented as E of S, and this summing point where this is these feedback path is meeting here along with this R of S, okay, it is called as plus or minus B of S, okay. Since they have mentioned it in negative feedback system, I am doing it for plus or minus B of S, okay. I am considering it for this normal feedback system, okay, how it is represented. In case of negative feedback system, you should be writing only minus B of S and doing the rest of the derivation. But here in this case, I have considered both of them, that is plus or minus, okay. Yeah. If they ask for positive feedback, you should be considering plus. If they ask for negative feedback, you should be considering minus. Okay, from the above figure we can see that this E of S is equal to R of S plus B of S. These two R of S and B of S here are getting summed up, and this is the output generated E of S. So that's why E of S is equal to R of S plus or minus B of S. Also, this B of S is equal to C of S into H of S. If you see it carefully, from the output side, this is the output generated along with this feedback path. So these both, if we multiply together, this is the result we get, that is B of S. So that's why B of S is equal to C of S into H of S. So that's why in place of B of S here, replace it by C of S into H of S and rewrite the equation, that is E of S is equal to R of S plus or minus C of S into H of S. Name it as equation 1. Also we can see that C of S is equal to E of S into G of S. Okay, this E of S into G of S, if we multiply it, this would be the output generated C of S. So that's why C of S is equal to E of S into G of S. So from this, replace some of the interchange the terms, that is E of S, you make it as C of S divided by G of S and name it as equation 2. So now consider equation 1, that is E of S is equal to R of S plus or minus C of S into H of S. So E of S is equal to R of S plus or minus E of S into G of S, since C of S is equal to E of S into G of S. So that's why in place of C of S, replace it by E of S into G of S into H of S. So bring this plus or minus E of S into G of S into H of S to other side. So since it is plus or minus, it would be remaining as it is. So E of S plus or minus E of S into G of S into H of S is equal to R of S. So here, since we have taken E of S is equal to C of S by G of S, so replace in place of E of S in this equation, replace it by C of S into G of S. So C of S divided by G of S. So C of S by G of S plus or minus C of S by G of S into G of S into H of S. So we can cancel G of S here is equal to R of S. So that's why C of S into G of S plus or minus C of S into H of S is equal to R of S. So in this term, take the LCM here. Okay, after taking the LCM, what we are getting, C of S plus or minus C of S into H of S into G of S divided by G of S is equal to R of S. So C of S plus or minus C of S into H of S into G of S, and this G of S you multiply it here, so G of S into R of S. So here in this equation we can see that C of S is common, so I have taken it outside and written the rest of the terms, that is 1 plus or minus G of S into H of S is equal to G of S into R of S. So just for our transfer function, that is the relationship between output and input, that is represented by C of S into R of S. Since for this block here, this is the output and this is the input, so C of S by R of S, if we compute it, we would be getting, just replace the term, that is G of S divided by this, you bring it to other side, it would be division, it would be coming to the denominator side. So this is the final expression we get, C of S by R of S is equal to G of S divided by 1 plus or minus G of S into H of S. Okay, for negative feedback system we should be considering 1 minus G of S into H of S. For positive feedback system we should be considering 1 plus G of S into H of S. Okay, so this is the derivation part. Hope you understood this. So please note it down. This is very important.